So this is a simple exercise just demonstrating how we determine voltage relationships between nodes even when they're not directly connected, but may be connected through other nodes, and how we handle the voltages between them. So here you see we have four nodes, 0, 1, 2, and 3, and this is how they're connected, and then we're given some information about the voltage relationship between these. So they want us to determine the voltage, the node pair voltages. So calculate the node pair voltages. So to do that, let's see what node pairs we have. So we'll go ahead and just write here nodes. And so we know we'll have node 0. So it doesn't make any sense to talk about between 0 and itself. So we'll have 0, 1. We will have 0, 2, and we'll have 0, 3. All right, so that's all the ones that can relate to 0. So next, we will have node 1. Well, we've already done it with 0 here. Doesn't make sense to do it with itself. So then we'll have 2 and 3 here. And then we'll have node 2. We've already done it with 0. We've already done it with 1. Doesn't make sense to do it with itself. So we're left with 3. And then that leaves node 3. Well, node 3 has already been taken care of with 0, 1, and 2. So these are our node pairs that we will need to look at. And so let's do some calculating and see if we can find the relationship between these. Okay, so for the first one, we're going between node 0 here and node 1. So when we do that, we need to look at the voltage between them. So we start at 0 and we go here, and that's a plus 6. So I'll just call this voltage 0, 1. And we'll say it's plus 6, and then we go from here to here, which gets us where we want to be. That's another 9 volts, so it's plus 9, and so that one's going to be 15 volts. So now we can look at the next one. So we'll say from 0 to 2. So in that case, we're going from this node to this node. So when we do that, we have V02. So again, we go from here to here. That's a positive 6 from here to here. That's a positive 9. And then from here to here, we hit the negative first this time. So that's a minus 3. And so from 0 to 2, that should be 12 volts. So we've determined that one. And finally, we want to go from 0 to 3. Well, that one's easy. We know that one directly. So V03 is just equal to 6 volts. So there's our first ones in relation to 0. So next, we're going to look at what's remaining with node 1. So in this case, we're going to go from 1 to 2. So that's here. So V1 to 2. And here we see if we go from 1 to 2, we encounter the negative first from our starting point. So that one will be minus 3. Simple enough. Next, we'll go from 1 to 3. So that's from here to here. So V13 then is going to be from here to here. Again, we encounter the negative from our node. So that's just a minus 9. So V1 to 3 is minus 9. And then finally, we're going to look at the last node pair that we have, and that's between 2 and 3. So when we do that one, start at 2, go from here to here. This is V23. So that would be equal to a plus 3. go from here to here. Again, we encounter the negative first, so then that is a -9. So therefore, V23 would be -6. So one thing just worth noting here, so we can reverse the order on these. So instead of V01, if we did V10, then that would just be -15. It just changes the sign. So V20, that just means we start in the opposite direction and go. That would be -12. V30 would be -6. V21 would be a +3. V31 would be a +9. And then V32 would be a +6. So there, it just determines by which direction you go. We always go from the lower number to the higher number node here on this side, and then we go from the higher number node to the lower number node on this side.